Hello everyone, let's look at for sum. Before we even look at the problem statement, if you haven't looked at my solution for 3-sum and 3-sum closest, feel free to pause the video and look at those two videos first. That's question number 15 and 16. Let's have a look at the problem statement. We are given an array nums of 10 integers and an integer target. Are there 4 elements A, B, C, D such that the sum of them is target, and we want to find all unique quadruplets in the array. For the first example, the input nums is 1, 0, -1, 0, -2, 2. Target is 0. The output has 3 elements. First array is -2, -1, 1, 2. Second, -2, 0, 0, 2. Third, -1, 0, 0, 1. To solve this problem, let us first quickly recap what we did for the 3-sum problem. We sorted the input array and then used 2 pointers algorithm. In specific, we first sort the input array ascendingly and then loop through the array from the beginning. And then we have basically fixed one value. And then we have 2 pointers point at the left and right of the array. Then we move left and right pointer to find the rest 2 values until left and right pointer meet each other. Here, we have a really similar problem. Instead of having one loop to fix one value, we can have 2 layers of for loop to fix 2 values, and then, to find the rest 2, we just use the same 2 pointers algorithm. Let's look at the code. First, let us make sure the length is right. And then, let's sort the input array. Let's save the length, and then we can have our first layer of for loop. And here, I, the boundary for I is less -3. It's because obviously we have 3 other values on the right side of I. And then we can have our second for loop. Same thing for J. J just at the right side of I, and J should less than len -2. Let's move on to our left pointer and right pointer. Left is at the left side of J, and right is at the far right at the end of the array. As long as the left is less than right, let's have this sum value. So we have those first 2, those are fixed, and then let's add our nums left and nums right. And then we do the check if sum equals target. If equals, that's good. We need to push all these 4 values. And then they should be saved in an array. And then we keep moving left and right. And then, if the sum value is less than target value, we need to move left pointer. Otherwise, we move right pointer. then all the way in the end, we'll return our result. Now, we have the basic structure for our two-pointer solution. Let's look at how we can optimize this. One thing I can think of is, for this loop, so starting from I, if the sum value for the first 4 consecutive numbers is larger than target, then we can break our loop. So this is because the nums array is already sorted. So we cannot find a smaller sum value if we move I further right. And we have the same case for our loop for j. And we need to return all unique quadruplets. That means if we see a repetitive I or j, we need to skip them. Let's look at the code. And same thing for j. Same thing for our left and right. What we did here is for I, j, left and right, as long as we see a same value, we just keep moving the index, whatever the direction it is. And there's another tiny place we can optimize the loop. Let's look at here. So what we have here is fixing our I, and then we add the most largest 3 values. If the sum value is less than target, that means we don't need to keep looping, we just need to move our I to its next. And we can apply the same thing for j. And then let's try to sum it. It looks good. So for the whole solution, we have 2 for loop, and then we have our 2-pointer solution, left and right. So if we just move the outer for loop for the I, then the inner loop and the while, that's basically the solution for our 3-sum. So let's look at the complexity here. This is n the power of 3. So because we have this 2 layers of for loop and we have this while loop. Let's look at the space. It's O of n. If you have any questions, please leave a comment below. Thank you for watching.